Alright, so I wanted to go over the how to do powers of monomials examples. And so the directions tell us to simplify. And remember, with the power to a power, you multiply the exponents. And if there is more than one base or there's coefficients, they also get raised to that power. So I'm going to start off a little simply and then get a little bit more complicated. So we have the quantity x cubed and we want to raise it to the fourth power. Well, we can think about this as, what does to the fourth power mean? What it says, it's a short way of writing a multiplication problem. So we really have x cubed times itself, times itself, times itself until I end up with 4 of them. And if you remember multiplying monomials and the bases are the same, all you're going to do is add the exponents. And so we would get x to the 12th. Now, the shortcut, or the fast way of doing this math, says, hey, I had 3 4 times, so why don't I just go back to the beginning and say I have 3 4 times, which gives me x to the 12th. So that is a nice little way of thinking about it, power to a power. All right, and it doesn't matter if I have a numerical base. This is a 6 to the second power, and I'm going to raise it to the fifth power, which would really be saying 6 squared times 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 6 squared. Oops, I think I did too many. Yep, I only need a total of 5. 1, 2, 3, 4, 5. I've got them all. And then again, that would be a 6 to the 2 plus 2 plus 2 plus 2 plus 2 power, or 6 to the 10th power. And again, if you think about powers to powers, we're taking 6 squared and we're going to raise it 5 times. So that gives us 6 to the 10th power. So really this idea is a time saver. Okay? So I'm going to show you again, step by step, how this happens. So here we've got, we're going to raise to a power, which means we're going to multiply. Now if you don't see an exponent, he's there, he's just the number 1. So we're going to raise x to the third power, and we're going to raise y to the third power, giving us a grand total of x cubed, y cubed. Okay? And if I have the monomial 2x squared y cubed, and I want to cube it, we're going to cube the 2, the coefficient. Now remember, he does have an exponent of 1 if you don't see it. We're going to multiply by, oops, sorry, that should be a 3. And then x squared cubed and y cubed cubed. So we get 2 cubed, x to the 6th, y to the 9th. And the one thing to remember is we said if the exponent on a numerical base is 5 or less, then you actually have to multiply it out. So you need to tell me what 2 cubed is, which remember, it's just going to be 2 times 2 times 2 for a grand total of 8, x to the 6th, y to the 9th. And that's that answer. And then we've got, let's see, probably fit one more on this screen. We have negative 3/4 x cubed y, and we want to square that. Oh, wait a second, wrong problem. Try this again. We've got negative 3/4 a cubed b to the 5th. And all of that we want to square. So here's what we're going to do, and this is the one for some reason I have a lot of issues with. We want to make sure we understand that negative is actually negative 1. We're going to square that, and then when we square a fraction, we square the numerator and we square the denominator. And then we've got a cubed squared, b to the 5th squared. So a negative to an even exponent is a positive, so we get positive 1. 3 squared is going to give us 9. Remember, we have to multiply it out. 4 squared is going to give us 16. 3 times 2 gives us a to the 6th. And then we get b. 5 times 2 gives us to the 10th. So that's one way to write the answer. The other way is to write 9a to the 6th, b to the 10th, all over 16. So that is kind of an option when you have a fraction involved. Okay? Alright, let's keep looking at some more complicated problems. And by complicated, I mean there's just more going on in them. We have multiple operations here. We're multiplying 3 monomials together. Oops, let's make that a positive 3. So 3x cubed y. But we're going to square that one, and then we're going to multiply it by negative x y to the 4th, and we want to cube that. So we're still following order of operations, and order of operations says you need to take care of exponents first. So we're going to get negative 1, because that's the first monomial. And, oops, sorry, change back to black. And then inside we're going to cube the 3, we're going to square the 3. And we're going to cube, or squared the x cubed, and we're going to cube the y. And then over here, I should use brackets, and we're going to take negative 1, because that's what goes with that negative sign, and we're going to cube that. We're going to cube x, and we're going to cube y to the 4th. Okay, so the first monomial is still negative 1. 3 squared is 9. 3 times 2 gives me x to the 6. 1 times 2 gives me y squared. And then negative 1 cubed is still going to give me a negative 1. And then 1 times 3 is 3. 4 times 3 is 12. So now what I have is a monomial problem. And when I multiply monomials, I'm just going to multiply the coefficients. So I have a negative 1 times a 9 times a negative 1. But now I have to go back and add exponents on like basis. So I got to keep my rules straight. Let me erase that, make that neater. So 2 negatives make a positive. 1 times 9 times 1 is 9. 6 plus 3 is 9. 2 plus 12 is 14. And that's that answer. Alright, let's do another one. I think I can get them in over here. This one we have the quantity for a squared. We want to cube that, and then we're going to try to add that to negative 2 a cubed squared. Okay, so I'm going to kind of shorten out my work on this one because we should be used to negatives now. So this one I'm going to cube the 4 because it's 1 times 3 is the exponents. I'm going to cube the a cubed, so that's one monomial. Over here I'm going to take negative 2 and square it, so I'm going to take care of the negative and the squaring of 2 at the same time. Okay, so 4 cubed, remember that's 4 times 4 is 16, times 4 is 64, 2 times 3 is 6, a negative to an even power is a positive, 2 squared is 4, and 3 times 2 is 6. At this point what you're going to be looking for is, do you have like terms? And remember, like terms are going to have the same variable with the same exponent, and that's exactly what we have. So technically what we're doing is factoring out the a to the 6th and then doing the math with what's left behind, and we get 68 a to the 6th. Now I'm just going to go back and talk a little bit about what should I be seeing when you're doing your homework. Again, you start with the original problem, many of you would be able to do all the math in your head and then combine like terms. So the other steps, I call them brain steps. They're not mandatory for you to share, but they are something interesting for us to look at. All right, let's do a couple more. This will be number 8. Oops, sorry. And this one's going to be kind of a doozy because it's got a lot going on. So we have 2x squared y. You want to raise that to the 4th power. To that, you're going to add negative 3x to the 4th y squared that you're going to square. And then to that, you're going to add negative 5x cubed y that we're going to square and then multiply it by xy squared. Okay, so a lot of things going on. Following order of operations, we're going to take care of all those exponents first. So this guy gives me 2 to the 4th. I'm going to get 2 times 4 on the x. I'm going to get a 4 on the y. I'm going to add to that negative 3 squared is a positive 9. And I'm going to 4 times 2, y2 times 2. Over here I'm going to have to do parentheses because after I square the first monomial, I then will have to continue to multiply by the second one. So a negative squared is a positive, and 5 squared is 25. Then I have x cubed squared y squared, and then multiply that by xy squared. All right, so let's do out the math with what I can. 2 to the 4th power is 2 times 2 times 2 times 2, which would give me 16. X to the 8th, y to the 4th, plus 9, x to the 8th, y to the 4th. And then over here, I'm going to get 25 x to the 6th, y squared times the xy squared. So if you notice over here on the left 2 terms, they are like terms. So all I'm going to do is add up their coefficients. I can do that now. I don't know if I'll be able to do more with the second term, but we'll just have to wait till I get the multiplying done. But 16 plus 9 is 25. And then it stays x to the 8th, y to the 4th. Remember, when you combine like terms, only the coefficients combine. Now, the other guy, we're going to now multiply 25 times 1. And now we're going to add. I have x to the 6th times x for a total of x to the 7th. Whoops. And then I'm going to go ahead and y squared times y squared. I'm going to add those exponents, and 2 plus 2 is 4. And if you notice, don't quite have everything that I need. So I'm going to go ahead and leave the answer like that. I cannot combine anything more, and I am done. Okay. So I have a couple more, but what we're really going to be practicing are negative exponents. And remember, all a negative exponent is, oops, sorry, that's not what I wanted to write. Just means that our base is in the wrong location. A base can either be in a numerator or in a denominator. And so if it's negative and it's in a numerator, put it in the denominator. If it's negative and in the denominator, put it in the numerator. Okay, so I'm going to show you the best way to do this. And that would be to raise a power to a power means to multiply. So a negative times a negative is a positive. 1 times 2 is 2. Oops. So I ended up with a positive exponent, which is good. And then I'm going to just go and do the math out. So I get negative 16. Okay. What if we have multiple things to do? We have 8 cubed times 8 to the negative 2nd all over 8 squared. And then I want to raise that whole thing to the negative 2nd power. So resist the temptation to multiply everything by negative 2 in terms of exponent. get down to one value with one exponent and then raise to the negative second power. That's going to be my best suggestion to you. So in the numerator, we're going to add the exponents, which gives me 8 to the first power over 8 squared, raised to the second power. Now in the division problem, we're going to subtract the exponents. So we get 8 to the negative first power to the negative second power, and then we're going to multiply. And we get 8 to the negative first times negative second, which I'm going to just kind of put up here, which gives us 8 to the second power, which will give us a final answer of 64. Okay. All right, let's do another one here. We have the quantity 5a to the negative second power. We want to cube that. So again, we got to remember we got to cube each item. So we're going to cube the 5, and we're going to cube the negative 2. 5 cubed is 5 times 5, 25, times 5 is 125, and we have a to the negative 6 power. So here's the thing you need to pay attention to. The exponent is only attached to the thing directly in front of it. Directly in front of the negative 6 is an a. So it's only the base a that is in the wrong location. The 125 has a positive exponent, so he stays in the numerator. A to the 6 goes into the denominator, and he becomes a positive 6 when he moves into the proper location, and that's the answer there. All right, I've got 2 more examples for you, and then we'll be done. We have the x, oops, let's try that again. X to the negative 8th times x cubed, and I want to raise that to the 4th power. So again, when I'm multiplying monomials and the bases are the same, I add the exponents, and that gives me a negative 5 on the x, and then I want to raise it to the 4th power. And then I'm going to go ahead and multiply the exponents, because that's what you do when you raise a power to a power, and you get a negative 20 on the x, which basically says the base needs to move into the other location, which would be the denominator, and then he becomes positive. So again, let me just reiterate, what are the mandatory steps? Original problem, the result of doing the multiplication, the result of raising to the power, and the result of writing your answer with positive exponents only. And last one, we have x to the negative 5th divided by x raised to the negative 3rd power. So when we are dividing monomials, we actually subtract the exponents, and that gives us a negative 6. And then we're going to raise the power by multiplying them. We get x to the 18th. Positive exponent, he's good where he's at, and we are done. All right, good luck.